here in section 5.2 on page 7. First thing is talking about how to use your calculator, obtaining a binomial probability distribution using a TI-8384 calculator. First one's find the probability that x is equal to a value x. In order to do this, we are going to use binom PDF. And the other one's going to be less than or equal to x, which is going to be using binomial CDF. And then we have an issue of what happens when we have a greater than symbol, and that's going to involve us using the complement of 1 minus the probability that x is less than or equal to x, which would be using this binom CDF. So let's go ahead and look at our calculator first. And I want you guys to go to second, vars. And on the older style calculators, it was 0 and A, and on the newer style calculators, actually for me, it's A and B. So remember, change it depending on what calculator it is that you have. I'm just going to go ahead and select binom PDF just to see the setup of this. So the older style one that we have, you're going to put in your N values for your trials, your P values for your probability, and your X values. This is the number that need to have a certain characteristic. And then we will go to paste. Those of us with the older style calculators are going to type it in just this way. So first thing is we have an example down below. This is according to flightstats.com. American airline flights from Dallas to Chicago run on time 80% of the time. Suppose that 15 flights are randomly selected and the number of on-time flights are recorded. So the total number of flights that we have are 15 and the probability of them being on time is 0.80. Find and interpret the probability of exactly 10 flights, and exactly would be the probability that x is equal to 10. This is going to be using binom PDF, because it is equal to. We have 15 flights, probability is 0.80, and the number of flights that we want on time is x, which is 10. We're going to go ahead and put all those numbers in. I'm going to go down to paste. Hit enter. It looks just like the older style calculators. Select enter one more time. I'm going to go ahead and round this 4 decimal places, so 0.1032. So the probability of 10 out of those 15 flights being on time is equal to about 10%, or the probability would be 0.1032. The second part on here says find and interpret the probability of fewer than 10 flights. Fewer is less than 10. And if you notice up here with our binom CDF, the value has to be less than or equal to. It cannot be just strictly less than. So this is equivalent to the probability that x is less than or equal to 9. So we can go ahead and try our binom CDF. N is our number of flights, which is still 15. Probability of it being on time is 80%. And this time our x value is 9. So again, we're going to go second, vars. I'm going to go down to binom CDF, hit enter. The trials are 15, the probability is 0.8, and my x value this time is 9. Down to paste. Should look exactly like the older style calculators. Enter one more time. And again, we're going to round this 4 decimal places, so I get 0.0611. Okay, the next one that we have is the probability that at least 10 flights are on time. So the probability that at least is going to be x is greater than or equal to 10. And since we're dealing with greater, this is going to be 1 minus the probability that x is less than or equal to 9. And this is the same probability that we found straight up above, so I'm going to go ahead and steal that number. I'm going to do 1 minus 0.0611, which is going to be 0.9389. Again, these are discrete values. Remember, there's only 9 flights, 10 flights, 11 flights, so we're counting by whole numbers here. No decimals. The next one says find and interpret the probability that between 8 and 10 flights are on time. So the probability that between 8 and 10 flights are on time is going to be equal to the probability that x is equal to 8, plus the probability that x is equal to 9, plus the probability that x is equal to 10. There are a few other ways to do this, but this is the easiest way to do. So we're going to go ahead and do binom PDF 3 different times with 3 different x values. The n value still stays 15 and our probability is still at 0.8. So go ahead and see if you can calculate each of these individually. Your total, though, when you add that up, should be equal to 1600. So 0.1600